Good morning and welcome. In the topic gaseous state, today we are going to learn stoichiometry problems involving gas volumes. Stoichiometry problems involving gas volumes. Before that, I want to explain what is stoichiometry equation or stoichiometry reaction. A balanced chemical reaction. Stoichiometry reaction is a balanced chemical reaction in which quantitative relationships between reactants and products are given. It is a balanced chemical reaction in which quantitative relationships between reactants and products are given. So, first we are going to solve one simple problem. The problem reads like this: when 0.0100 mole of potassium chlorate. The formula of potassium chlorate is KClO3 is heated in a test tube. How many liters of oxygen can be produced at 298 Kelvin and 1.02 atmosphere? So this is the problem. Read the problem carefully. This stoichiometry reaction is also provided in this problem. So KClO3 is potassium chlorate. Potassium chlorate is heated. Heating is represented by delta sign. MnO2, which is used as catalyst, a substance which increases the rate of the reaction without participating in the reaction, is called catalyst. Manganese dioxide is the catalyst. When you heat small amount of potassium chlorate, its quantity is also given 0.0100. Here, for our simplicity, I remove these two zeros. The value will be same, 0.01. Mole of potassium chlorate is given. It is heated in a test tube, and what is asked? How many liters of oxygen can be produced? That means how many liters of this oxygen will be produced from 0.01 mole of potassium chlorate. This is the problem. And what is given? Temperature is given at 298 Kelvin and pressure is given in atmosphere 1.02 atmosphere. So let us solve this problem. I write first solution. Then first write the given data. Whatever is given, you write there. Potassium chlorate, the reaction is given in the problem. 2 moles of potassium chlorate when heated in presence of manganese dioxide catalyst, it produces 2 moles of potassium chloride and 3 moles of O2, oxygen. So I write here, in this reaction, the quantitative relation is given. So I first write the weight of the potassium chlorate is given. Therefore I write here mass of KClO3 is equal to 0.01 mole. It is heated in a test tube. How many liters of oxygen can be produced? Therefore, I represent here phi of O2 we have to calculate. At 298 Kelvin, temperature is 298 Kelvin and pressure is given in atmosphere. P is equal to 1.02 atmosphere. We have to solve this problem. So, for this problem, we are going to use the relation P into phi is equal to nRT. That means volume of oxygen and moles of oxygen we want to calculate. So in this equation, pressure is known, volume we want to calculate, number of moles of oxygen are also not known. Our gas constant is fixed, its value is known. Temperature in Kelvin is also given. So I write here N is equal to mass of moles of oxygen I want to calculate, mass of KClO3 divided by molecular weight of oxygen. Molecular weight of oxygen. Sorry, we cannot use this relation. I write here how to calculate moles of oxygen. Two moles of potassium chlorate, 2 mole of KClO3 give 6 mole of oxygen, 6 mole O2. Therefore, this value is also given. N is equal to 0.01 mole. Therefore, I write 0.01 mole KClO3 is equal to how much mole of O2. From this relation, we calculate mole of O2. So that is equal to. Simplify this. Cross multiplication divided by 2. So I write here 0.01 multiplied by 6 divided by 2 that is equal to. sorry, 3 moles of O2, 3 2 mole of KClO3 give 3 mole of O2. Therefore, here not 6, here is 3. Simplify, very simple calculation. 3 divided by 2, 1.5 into 0.01. The answer is 0.015 mole of O2. So N we have calculated here. Now I am going to use this relation. PV is equal to nRT. So calculate volume of oxygen is equal to moles of O2 NO2 into R into T divided by P. So that is equal to, substitute the values, 0.015 into R 0.0821 liter atmosphere per Kelvin per mole into temperature 298 Kelvin divided by P. The pressure is given 1.02 atmosphere. So simple calculations. Make these calculations by using calculator and find out the answer. The answer is 0.360 liter of oxygen. So when 0.01 mole of potassium chlorate is heated, it gives 0.360 liter of oxygen. Simple problem which is solved in your textbook as illustration. I illustrated this problem. Now we are going to solve the next problem. Very simple problems. Remember, here in these problems we are going to use 2 or more steps. Therefore, it becomes somewhat difficult. Not actually, it is difficult. PV is equal to nRT, number of moles. These are the quantities required to solve these type of problems. The example 5.9 I am going to solve from your textbook. The rapid reaction between, I write the problem, the rapid reaction between sodium azide its formula is NaN3, sodium azide, and iron 3 oxide, ferric oxide. oxidation state of iron is +3. Its formula is Fe2O3. Fe2O3 is initiated by a spark in automobile airbag. The overall reaction is like this: 6 moles of sodium azide, which is in solid state, plus ferric oxide Fe2O3. This is also solid. It gives sodium oxide, which is in solid state, plus twice Fe iron, which is in solid state, plus 9N2, which is in gaseous state. The rapid reaction between sodium azide, that is 6 moles of sodium azide, which is in solid state, and iron oxide in solid state, is initiated by spark in automobile airbag. The overall reaction is like this. So this is stoichiometric reaction involving gas volume. This reaction is also provided in the problem. First we have to find out how many grams of sodium azide. We have to calculate grams of this sodium azide. How many grams of sodium azide would be required to provide 75 liter of oxygen, of nitrogen, 75 liter of nitrogen at 25 degrees centigrade. So T is equal to 25 degrees centigrade and 748 mmHg. Pressure is given. P is equal to 748 mmHg. So this is the problem that we are going to solve. The main reaction, the main equation is, or the main formula is, PV is equal to nRT. By using this relation, we are going to solve, but before that, we have to calculate number of moles, etc. So I write the given data: 9 gram of NaNO3, mass of NaNO3 is equal to 9 gram. This is provided. And volume of nitrogen, Phi of N2, is equal to 75 liter. 75 liter. What we have to calculate? How many grams this we have to calculate. Grams of NaN3, grams of sodium azide. We want to calculate this. I think the problem will be clear and the values are correct. By assuming whatever written is correct, I am going to solve this problem. So look here, temperature is given in degree centigrade. We want the temperature in Kelvin scale. Therefore, I add plus 273, that is equal to 298 Kelvin. 298 Kelvin. This pressure is given in terms of millimeters of mercury column. But we want the pressure in atmosphere. The pressure in atmosphere. mmHg I want to convert into atmosphere. The simple formula is 748 divided by 760. 760. If you cannot understand this, you write the relation like this. 760 mmHg is equal to 1 atmosphere. You know this. Therefore, 748 mmHg is equal to how many atmosphere? Solve this. Cross multiplication. 1 into 748 divided by 760 divided by 760. So I write the direct answer here, 748 divided by 760. The answer is 0.984 atmosphere. I want space, therefore I remove this. So the pressure we have calculated in atmosphere. Now write the relation PV is equal to nRT. nRT, ideal gas equation. Volume of nitrogen into is equal to moles of nitrogen. Moles of nitrogen. So I want to calculate moles of nitrogen. Moles of nitrogen is equal to, I take this on left hand side, P into volume of nitrogen divided by R into T. Check whether it is correct or not. So substitute the values, that is equal to pressure 0.984 into volume of nitrogen 75.0 liter. 75.0 liter divided by R is gas constant. So substitute its value 0.0821. Sometimes the value of R is provided in question paper, sometimes it is not provided. Temperature in Kelvin 298 Kelvin. 298 Kelvin. Make these calculations by using calculator. I tell you the direct value, that is equal to 3.02 mole of nitrogen. So number of moles of nitrogen is equal to 3.02 mole of nitrogen. What we have to calculate? Gram of sodium azide. So NaN3, look here, sodium azide, NaN3. This is ionic compound. This is the positive part and N3 is the negative part. This is cation, this is anion, this is positive radical, this is negative radical. N3 minus is azide ion. This ion is called azide ion. We have to find out grams of NaN3. So, sodium azide, calculate its molecular weight. So before that, we calculate like this. I remove this. NaN3, we calculate its molecular weight after 2 minutes. So here in the problem, 6 mole of azide give 9 moles of nitrogen. This I have written azide, which is given in your problem. In short, I have written 6 moles of azide give 9 moles of nitrogen. So write 9 mole of nitrogen is obtained from 6 mole of NaN3. Therefore, 3.02 mole of nitrogen will be obtained from how many mole of sodium azide? Solve this. Cross multiplication. Something is wrong. I explain in different manner. Yes, it is 3.02 mole, it is correct. So we are solving, I write once again, 9 mole of N2 is obtained from 6 mole of NaN3. Therefore, 3.02 mole N2 will be obtained from cross multiplication, that is equal to 3.02 into 6 divided by 9. Simple calculations, you make the calculations, I shall tell you direct answer, that is equal to 2.01 mole of sodium azide, NaN3. Now, this is second step of the problem. These problems are somewhat difficult because we have to calculate in 2, 3 or 4 steps. So, this is mole of sodium azide. Sodium azide NaN3. Calculate its molecular weight. Atomic weight of sodium is 23 and atomic weight of nitrogen is 14. Atomic weight of sodium is 23, atomic weight of nitrogen is 14. Calculate its molecular weight. 23 plus 3 atoms of nitrogen, 3 into 14. That is equal to 23 plus 48, 42. That is equal to 65. 65. Molecular weight of sodium azide is 65. One mole of sodium azide gives 65 gram of NaN3. Therefore, 2.01 mole of sodium azide will give how much gram of sodium azide? That is equal to cross multiplication 65 into 2.1, 65 into 2.01 divided by 1, that is equal to calculate approximate answer 131 gram. 131 gram. So here we have to calculate the grams of sodium azide required. So sodium azide required is equal to 131 gram. This is the example number 5.9, which is given in your textbook on page number 20 and 205. We solve one more example and today we are going to stop here. So simple relations and simple problems are there. As compared to physics subjects, the problems in chemistries are easy and there are less interconversion of units. I write the problem. This is exercise number 5.9. How many liters of chlorine gas, I write how many liters of chlorine gas can be obtained at 40 degrees centigrade at 40 degrees centigrade and 787 mmHg from excuse me from 9.41 gram of hydrogen. Hydrogen chloride, that is HCl. According to following equation. The equation is given twice KMnO4, which is in solid state. Potassium permanganate is in solid state plus 16 moles of HCl, which is in aqueous state. It gives the products are these are reactants, and here 8 moles of water are produced, which is in liquid state, plus 2 moles of potassium chloride, which is in aqueous state, plus 2 moles of MnCl2 manganese chloride, which is also in aqueous state, and plus 5Cl2, which is in gaseous state. This is stoichiometric reaction. In stoichiometric reaction, it is perfectly balanced. The reactants and products give the quantitative relationships between reactants and products. This reaction gives quantitative relationship between reactants and products. These type of reactions in which the number of atoms on left hand side and the number of atoms on right hand side of each element is same. It is perfectly balanced. Therefore, it is stoichiometric reaction and it is involving gas. Therefore, we are going to solve the problems related to stoichiometric reactions involving gas. In first example, oxygen is involved. In second example, nitrogen is involved, and now chlorine is there. So first, write the given quantities. How many liters of chlorine gas can be obtained? So right here, we want to calculate volume of chlorine. Here, volume of chlorine, 5 moles of chlorine produced from 2 moles of KMnO4. We have to calculate the volume of chlorine. At 40 degrees centigrade, temperature is given in degrees Celsius, convert into Kelvin, that is equal to 40 plus 273, 3 plus 0, 3, 7 plus 4, 11, 2 plus 1, 13. 3, 1, 3 Kelvin. Am I right? Yes, it is correct. Pressure is given 787 mmHg. P is equal to 787 height of mercury column. Now, convert this into atmosphere. Therefore, 787 divided by 760. You use the formula directly. That is equal to, the answer is 1.03 atmosphere. .41 gram of hydrogen chloride. See here, the weight of HCl is given. Mass of HCl is equal to 9.41 gram. 9.41 gram. The mass of HCl is given 9.41 gram. So from this equation, we want to calculate volume of chlorine. Volume of chlorine. 5 moles of chlorine are produced. We have to convert it into volume. Volume of chlorine. Moles convert into volume. So first, calculate moles of HCl. N of HCl is equal to mass of HCl divided by molecular weight of HCl. Molecular weight of HCl. That is equal to mass of HCl is 9.41. 9.41 divided by, calculate molecular weight of HCl. HCl, how to calculate? Atomic weight of hydrogen is 1 plus atomic weight of chlorine is 35.5. 35.5. These are known values are provided in the question paper. The answer is 36.5. 36.5. So that is equal to 9.41 divided by 36.5, that is equal to 0.257 mole of HCl. 0.257 mole. After this, use the relation P into volume of Cl2. Before that, we calculate 16 mole of HCl or 16 mole HCl. This 16 mole of HCl give 5 mole of chlorine. 5 mole of chlorine. Is it clear? 16 mole of HCl give 5 mole of chlorine according to stoichiometric reaction. Therefore, I calculate 0.257 mole HCl will be obtained from is equal to how much? Cross multiplication, that is equal to 5 into 0.257 divided by 60. Divided by 60. The answer is equal to 0.080 mole. 0.080 mole. So I clean the board, I remove whatever is unwanted. Then we are going to use the relation P into phi is equal to nRT. Ideal gas equation. We have to calculate volume of chlorine. Volume of chlorine. We know moles of chlorine. Moles of chlorine. Therefore, volume of chlorine is equal to moles of chlorine into R into T divided by P. Take this P on right hand side, that is equal to number of mole 0. Here one mistake. Here the answer is not 0.8 mole but 0.08 mole. 0.08. So mole of Cl2 0.08 into R, fixed value 0.0821 into temperature 313 divided by pressure P is equal to 1.03. Make these calculations by using calculator and find out the answer. The answer is equal to, sorry, one mistake. Yes, it is correct. Make the calculations. The answer will be 1.955 volume in liter. This is liter. So volume of chlorine is equal to near about 2 liter. So this is about stoichiometric problems involving gas volumes. So today I am going to stop here. We shall continue in next time. Thanks for watching. Thank you so much. Stay happy, healthy and blessed. Thank you so much.